Now, the last time we met, we talked about casting. Tukaangalia vile we make materials by melting metal and pouring that molten metal into molds. Kisha ikisolidify, we have a product. But we also saw that there are other processes, finishing processes that are necessary kuwezesha hili product yako ikae safi. And one of those processes in the industry ama kwa action ni filing. Niko sure kila mtu hapa ameona file mahali, nyumbani, kazini. You have ever interacted with a file. Now, filing is your process ya kutoa material. Those rough edges, which are usually known as bar, B-U-R-R, a bar. A bar is the rough edges. Zile ambazo the unwanted surfaces, the rough ones. Ukishamaliza kwa mfano casting, ushatoa chuma yako katika mold, it will have those rough edges, and we want to remove those rough edges, and we use a file as one of those tools. For now, the tool that we use is a file. Yeah, a file sana is usually a piece of metal which is high grade steel, ambayo iko na rows of teeth cut onto the face of that file. Now, this diagram over here just shows a cross-sectional, a very simple diagram of your file, and I will enlarge it so that kama kuna mtu anataka kuchora atachora. This diagram just gives us a very simple file, the nomenclature, the naming of a file, the parts of a file, so that in case kwa mtihani umeambia uchore hii na umeambia uname ni sawa, na pia ni vizuri pia kujua the different parts of a file. Now we have the handle. Sana the handle is usually mbao, wooden handle. Yeah? The tongue is that tapered. Tapered ni kumaanisha imeishia at an angle. Yeah? It is tapered to the end, and that is the part ambayo tunaingiza katika handle. Now the face is where we cut the rows of teeth. As you can see, we have teeth that are slanting in both directions. This edge, the final edge, inaitwa edge ama point. Yeah? That's the edge. We have the heel. The heel is just that space between, just before, ile place ambayo that doesn't have teeth, but just before ufike kwa tongue is known as the heel. And hainanga meno. Ukiangalia file, mahali file katika file na kuna habajakatwa meno, that is known as the heel. Now we classify files into four major categories: type of file, grade of cut, shape of file, and size. When we talk about the size, tunaongelea sana kuhusu the length. Utapata kuna file ndogo, kuna file nono, kuna file konde. Ni length, the thickness. So there are different sizes of files. Kulingana na the cut of the file, you'll find that some rows of teeth are let me mute Boniface. Boniface, please mute mic yako. Now, grade of cut, type of cut. Kutapata kuna file ambazo Now, type of cut, utapata kuna file ambayo maana yake ni row ni moja. We only have one set of rows in one direction. Kuna zile ambazo zitakuwa in Boniface, please mute, kuna kelele in your background. Kuna double cut, yeah? We have teeth ambazo ziko two. Those teeth that are cutting in one direction and others sloping in the opposite direction. Now kulingana na grade of cut, ni kama sandpaper. Kuna file ambayo itakuwa from rough na kuna file ambayo itakuwa smooth. Now the grade is usually determined by the distance between the rows of teeth. The rough files utapata kwamba those rows are space yake ni kubwa. The distance is big as compared to the smooth types of files. Utapata that the rows are the distance between the rows of teeth ni kidogo sana, to give you a smooth smooth finish ukifanya filing katika chuma. Now for the rough files tunatumianga kutoa big chunks, vibonde vikubwa katika chuma. If I want to do kazi haraka kutoa big chunks, I'll use a rough file, but for the smooth ones ni finishing touches. Shape of the file, kulingana na ile kazi ambayo nafanya. There are different shapes of files. For example, if I want to file a round corner, ama nataka kufile shimo, a hollow hole ambayo ni cylindrical in shape, I cannot use a flat file, I cannot use a triangular file, I cannot use a square file. Why? Because the cross-sectional shape of that is not circular, spherical in shape. So depending on the type of job that you're doing, and you can be able to pick the right file with the right cross-sectional area. So these are types of shapes, classification of shapes kulingana na classification of files kulingana na shape. It all depends on the type of work that you're doing. Ndio utachagua the shape. For the cut, the grade of cut, we have the rough, we have the second cut, we have smooth, we have bastard, we have super smooth. There are so many. Now I will play a very small video so that we can see the basics of filing in a workshop ama in the industry. So I want you to tell me whether you can be able to see it ama mnaweza isikia, so that I can make adjustments on my side. So please let me know. Tumeweza kuona. Have you been able to see? Tuko pamoja ama kuna shida? Can you hear me? Okay, yeah, so kama tuko pamoja, please unmute and say that you're present so that I know naongea na watu. Labda kuna mtu ameweka video akazima na microphone akaenda. So kama uko na mimi, unmute, sema uko present.
Present.
Asante. Now, I don't know whether we've been, in that video it has given us some basics. We have been able to see the type of cut. Vile nilikuwa nawaelezea, there are those files ambazo ziko na single rows of teeth cut into the face. Kuna zile ambazo kuna meno ambayo imekatwa on both sides of the face. Now, something very interesting in these types of cut is the angle. As you can see, the angle is going into in the anti-clockwise direction. So files usually have something known as negative rake angle. Rake, R-A-K-E, negative rake angle. It is sloping backwards. Are we together? In a slope backwards. Now, rasp cut, the easiest way I can explain ni ile grate ya kitchen. Kama umetumia grate ama kama unaona vile kuna vishimo katika hiyo grate. That is the easiest way I can explain how a grate file looks like. A rasp file looks like. Now, in that video, we have been able to see the types of cuts. We have been able to see the shapes, the cross-sectional shapes. We have been able to see the technique, and that is a very important part in filing. The technique, how do you file? Sana sana unapata katika workshop ama katika industry, na sio file pekee. Hacksaw, watu wanapenda kutumia mkono mmoja. No, please do not use one hand. Remember, these are hand tools, and they are meant to be used with your both hands if you have both of your hands. Now, if you are right-handed, utashika the handle with your dominant hand, which is right. If you're left-handed, utashika with your dominant hand. If you have noticed in that video is that they secure their workpiece, some of their metal, on a vise. That is usually known as a bench vise. Mahali ambapo unashikilia chuma yako inaitwa bench vise. So once you secure your bench vise, I mean your workpiece ama your metal on the bench vise, if you're right-handed, utajiweka ama you'll position yourself on the left side of the bench vise. If you're left-handed, then you'll position yourself on the right side of the bench vise. Okay? Now, for example, I'm right-handed. My bench vise is in front of me. Nitashika file yangu with my right hand, kisha I position myself on the left side. Now, we use the forward stroke. When we are cutting using the forward stroke. Tukisongesha mbele ndio tunatoa chuma. We are cutting pieces of metal. We apply pressure with your left hand. Since I'm right-handed, I will apply pressure using my left hand. Una apply pressure ukisonga mbele. That is when the cutting will occur during the forward stroke. When I'm returning my file on the backward stroke, I will release this pressure. But what I will not do is sitatoa file from my piece of metal. No. Nasongesha mbele na kata, narudisha file nyuma, lakini siachili file juu ya chuma. No. What I'm releasing is the pressure. While I'm cutting, naekelea pressure, nasongesha mbele. Nikirudisha nyuma, naachilia pressure, but I don't remove my file from my metal. So you do that mpaka mahali ambapo unataka kufile the required length ama the required measurement. Now, there is a tool ambayo sijui kama mmeona katika hiyo video. It's known as a square, an engineer square. Ni kitu inakaa right angle. Ni kama square mbili, ruler mbili zimeshikanishwa hivi. That is a very important tool. It is used to ensure that your surface is flat. Surface yako ni safi. Usikuwa na file unapata upande mmoja umekulika sana. No, it is very important. We'll see these tools as we move on to the next topic. Na ile time ambayo tutapata chance ya kuingia workshop tukirudi shule. Now, pia kuna kusafisha file. Remember that you are cutting, you are removing pieces of metal. So those pieces of metal, sana sana they get stuck. They weld themselves. Zinajiweld katika hayo meno. So if you don't regularly clean your file, then you'll find your file becomes useless. Remember when you're filing, you're producing heat. Na unakatakata pieces of metal. So those metals, because of the heat, they weld themselves inside the rows of teeth. So it is good to clean your file regularly. So you apply chalk on the teeth so that those bits do not zisiweld, they don't stick within the rows of teeth. Sawa sawa? Any question up to that point? Okay, now another process is very important. The processes that we've been talking about so far are to help you confirm if you are when you go in your final when you're doing your final project. These are some of the things that you will have to do in the workshop. And another important one is threading. Kila mtu hapa ametumia screw, umetumia nut na bolt. We have come across threads in our entire lives, tunajijua. So that process of creating those helical threads by successively cutting pieces of metal using a tool bit, a threading tool bit, that is known as threading. And this diagram is over here, let me enlarge it, will show us the nomenclature, some terms that are necessary for us to know so that we are able to calculate and understand threads tukienda kuzitengeneza. We just don't create them randomly. We need to know some of these terms and what they mean when it comes to threading. Now, this top part, on a thread is known as the crest. The topmost part of that thread inaitwa crest. Hapa panaitwa crest. The bottommost part ya thread yako is known as the root. Chini kabisa, that is known as the root. Now, the depth, how deep your thread is the difference between the crest and the root. Sawa. Now, thread angle is the angle that is formed by two successive threads. Zikipatana, that angle that is formed is known as the thread angle. Now, depending on the types of threads that you are making, because you have so many types, you'll find that this thread angle differs. Kwa mfano, this is a V thread, a metric V thread. The thread angle is 60 degrees. Now, lead is that distance. When I twist my screw, my bolt, one complete revolution, the distance that it moves from one thread to the other is known as lead. It is known as lead. When I twist my screw, that distance that it has moved inaitwa lead. Pitch is the distance between two successive threads. The crest of one thread to the other crest of the next thread. Successive, it has to be the next one. I cannot say from here. No. Good. This point, up to this point, is not a pitch. Reason being, those threads are not successive, they are not next to each other, so they have to be successive. Okay? Now, helix angle is this angle over here. The angle formed by the thread and that line, if I draw perpendicular, this angle, inaitwa helix angle. Remember, these threads are helical in nature. Ni kama DNA vile strand ya DNA inakaa. Zinaji twist. So that angle that is formed by that thread and a line that is perpendicular is known as the helix angle. Now, hapa katika lead, there is something I failed to mention. If I have a single thread, niko na thread ambayo ni single thread type of screw. If I want to calculate the lead, I will multiply 1 times the pitch. Remember, pitch is that distance between two threads. Is a distance between two threads. If I have a double thread type of screw, the lead, the distance that I will move once I twist that screw one complete revolution, is 2 times the pitch, and so on and so forth. If I have a triple thread, then I will take 3 times the pitch. The minor diameter is this distance from here to here. Mali root and root zinapatana. From one root on one side to the other side. That is the minor diameter. The major diameter is from one crest to the other side of the crest. That is the major diameter. Pitch diameter is usually center, iko katikati ya hizo mbili. Now, since we are not mandated to do calculations when it comes to this maneno ya threads, it's just good to mention the terms so that when you ukipatana nazo mahali, you will not be confused. Any question? Kuna swali? Now I will play a video so that we can see how these threads are usually made in the workshop. Yeah, I've mentioned the term lathe machine, so I am sure by now we are familiar of how it looks like. So please let me know whether it is clear and whether we can be able to see it. Now this is the lathe machine. Unaweka chuma yako katika maeneo yake, una set gear yako and you start the machine inaanza ku rotate. Now whatever is happening right now is known as machining processes. Specifically that is facing. You are reducing the length by cutting across the face of your metal. These are some of the processes that we encounter in the workshop. So machining workshop, kuna facing, kuna turning, kuna drilling, all that. Now these are external threads because they are on the outside of your metal. Yeah? Kuna zile ambazo unatengeneza ndani ya chuma yako. Now what you are going to see first is external threads. How do you make them? Now from those terms ambazo nili mention, kuna hizi pitch and the like. I can't just go to the workshop nikachukua chuma yangu nikaeka ndani ya lathe kisha nikaanza kufanya kazi. No. There are tables from books on the workshop, charts that will help you. Once you have done your calculation, I want my pitch to be 3 millimeters, 4 millimeters, 5 millimeters, then you will go to those charts, and those charts will show you at what speed at what speed should I rotate my lathe machine so that I can get the perfect threads. Which gear should I select to get that speed, and so on and so forth. Internal threading is the same. You do the same thing. You first do your calculations, determine the pitch of your threads and your depth. Kisha unaenda unaangalia from charts which is the right gear I'm supposed to select, which is the speed I'm supposed to rotate my lathe machine. Any question? Now this is using a lathe machine. Kuna wale ambao kama plumbers, they use hand tools. They do it manually. And I'll play a video so that we can see how mtu ambaye anafanya plumbing makes threads, external threads kwa zile pipe za maji. Now this is known as a pipe vise. It is still a vise, lakini this is specifically for pipes. Kile ambacho anafunga sasa is known as a G clamp. G clamp. Inaitwa clamp G kwa sababu inafanana na letter G. It is used to secure. If you have a workpiece na hauna mahali ambapo unaweza shikilia, unaitumia hizo G clamps for additional strength in your securing your workpiece. Yeye ametumia sasa kushikilia vise yake. He is using his G clamp to secure his vise. Now this is a pipe threader. This is known as a pipe threader. Inatumia ni kama ratchet. So akisongesha in the clockwise direction, that ratchet interlocks with that thread in die, ile ambayo inakata threads, ina lock. Kisha akienda clockwise inakata. Akirudisha anti-clockwise zina unlock. So he is cutting on the clockwise direction. When he is going in the anti-clockwise direction, hakati. In unlock, anarudisha anti-clockwise. Akirudisha clockwise tena ina lock, anaanza kukata tena. That is how a ratchet works. Kuna ile ratchet ya spanner. This is important because we won't have to keep on removing the tool ili tuanze kukata tena. It saves us that time. It improves accuracy. You can imagine if you're cutting threads, once you cut, unatoa tool, unairudisha nyuma tena, unaanza kukata. No, it will take a lot of time and we might interfere with the threads you have already made. Now, when we are cutting threads, it is very important to go in the anti-clockwise direction, especially when you are cutting by hand, using hand tools. Remember, threading is also, you are cutting or you are removing pieces of metal. So those pieces of metal have to be flushed out of the tool, and we do that by rotating that, we are rotating that ratchet, that pipe threader in the anti-clockwise direction. So it is important to remove those chippings. Always lubricate. Kwa sababu this is a cutting process, heat will be produced to ensure that your threads come out smoothly, hazina deformations, hazina cracks, and ensure that you keep on lubricating as you cut. Are we together? Tuko pamoja? Any question? Kama tuko pamoja, please unmute and say that I'm present. Thank you. Hi. Now, for we have different types of threads, right? Na kutegemea na ile kazi ambao unatengeneza your thread, we have the two major categories. I can make a thread for fastening purposes, ile ambayo tunatumia for kukazia, kama ile screw, bolt na nut ya kitanda. That is for fastening. We also have those for power transmission. Gears are also threads. Okay? So hizo sana are square. They are square in shape for power transmission because they usually have more stresses. They undergo huge stresses, so they should be able to withstand those stresses. So they're usually square in shape. For the fastening, we have them two major types, metric and Whitworth. They are both V in shape, but for the metric, ni sharp V. But for Whitworth, ni kama milima na mabonde. It is it's not as sharp. Its thread angle is less as compared to that of a metric. And for power transmission, we have sawtooth, we have acme, we have threads, we have square. There are so many. This is a diagram that shows some of those types of threads. Hii hapa ni the metric threads, the one that we are used to see. The thread angle is 60. This is the pitch, the distance between two successive threads. Now, the depth of the thread is, in this case, is usually given by 0.87 times the pitch. These are usually calculated. Okay. For the Whitworth, the thread angle is less. The pitch is still the distance between two successive threads. But as you can see, the depth of the thread of the Whitworth and that of the metric are different. For the metric, it is deeper, it is sharper, and so on and so forth. We have buttress, we have worm, we have acme, we have square threads. They are so different depending on the application of the thread. Now, what we have seen in the previous two videos is using tools, machines, to make internal threads, external threads. Now, we can also make internal threads by using hand tools. We have tools known as taps, we have tools known as dies that we use to make internal threads. Sana sana if you're making threads in shimo ambazo ni ndogo. If I want to make a thread ambayo shimo yake ni, the diameter of that hole is, let's say, 5 millimeters. I won't take my piece of metal kwa lathe machine. Hiyo itakuwa kazi mingi sana. So I can use that, I can do that by hand. Okay? Now, I will play a small video so that we can see how this is done by hand tools. So let me know whether you can be able to see it and whether you can hear what is happening. Give me a minute. Mpaka hapo tuko pamoja. We are together. I hope you are together. Now, what have you seen in that video? Nataka mtu ajitolea niambie ni nini ameona. What happened katika hiyo video? Milton, umeona nini?
I see him making a hole using the threading machine. Then after that akatoa hiyo uchafu. Ndio akadunga sio kitu ya kufunga.
Yeah. Now in this internal threads, kitu ya kwanza ambayo utafanya ni lazima utoboe shimo. You have to drill a hole so that you can unatengenezea passageway for your these are known as taps. What you are cutting with, what you are cutting the threads with ni tools ambazo zinaitwa taps. So you have to drill first using a drilling machine and a drill bit so that you can provide a hole ambayo ama passage for the taps to enter. Kisha ukisha drill kuna kitu ambayo aliweka ya pili, that is known as a countersink bore, countersinking. Let me enlarge this photo so that you can see what I mean. That second process is very important kwa sababu utapata when you're drilling, kwa mfano if you go to the workshop and you want to drill let's say 50 millimeter hole, unless kuna drill sana when you start drilling you don't go and pick a 50 millimeter drill alafu unaanza kutoboa shimo. No, drilling is done incrementally. Unaanza na ya 10 millimeters drill bit ya 10 millimeters, unaongeza unaenda na ya 30, 40 mpaka ukafika 50. This is to reduce those stresses that the drilling machine will experience. Ukienda kama unatoboa shimo kubwa alafu ukaenda ukachukua drill bit kubwa alafu ukaanza kutoboa shimo, that drill bit might break ama your drilling machine might break. So unatoboa pole as you increase the diameter of your drill bit. Now we use this second, this is known as a countersink bore. We use this kupanua hapo kwa entrance. Shimo yako unaipanua kidogo tu so that when you enter ukiingiza, this is known as the entering tap. An entering tap ya kwanza hiyo ndio inatumia sasa kukata those first you cut it, hiyo ndio inaanza kukata the threads. Now we use these three dies which are known as, these are usually known as serial taps, not dies, they are known as serial taps. So you insert the first one to do most of the cutting. Hiyo ndio unaanzia nayo, inafanya most of the cutting. Unaingiza ya pili, this second one is known as the plug tap. Hiyo sasa inafanya the additional cutting, but it is smoother. Meno yake ni less sharp as compared to this. Meno ya kwanza ni deep because it is doing most of the cutting. Ya pili meno yake ni sio sharp as such. Ni kufanya ni kukata tu kidogo. The third tap is known as the finishing tap. Hiyo sasa inahakikisha that the threads ambazo umetengeneza using the first two taps are smooth. So hiyo ndio inasafisha, inamalizia. Are we together? And once now you are satisfied with your threads, then you can insert a nut or you can insert another tap to ensure that the threads that you have made are not too shallow, are not too deep, are not too rough. They can be able to ukiingiza screw itaweza kuingia vizuri. Are we together? Now there is a tap. Kuna tap ambayo inaitwa nut tap. Now this nut tap combines these three as one, inakuwa 3 in 1. It has the functionality of those 3 serial taps in one. So itaanza na ile kazi ya entering tap, inafanya ya kukata, ina ile ya plug tap ya kukata kidogo and then the finishing tap ya kufanya the finishing touches. But we use a nut tap sana when we want to if mfano ile kazi ya haraka fast orders, when you don't have the time to keep on changing those 3 serial taps. When you just want to do a quick job, you use the nut tap. But it is advisable to do this kwa sababu the threads that you get are much smoother. Ni nzuri. Now in that video, you saw that once he turns that hiyo kitu wacha inaitwa nini, a ratchet ama a die holder. This is known as the die holder. that tool mahali ambapo unaweka tap is known as the threading die. So the die and the tap marry each other. They marry each other. Unazifunga vizuri using nuts. Ukisha secure hizo die holder, ukisha secure die na tap, then that die holder is usually inside, yeah, a threading die. So once you're turning your tap, now as you continue cutting, utapata kwamba kwa hiyo video vile umeona anazungusha once kisha anarudisha anti-clockwise. Remember, it's a cutting process, kwa hivyo una chip-ins. So ni muhimu kutoa those chip-ins from the hole. You can imagine once you are threading na hiyo chuma bado inabaki katika hiyo shimo, you'll find kama una grind. You'll be destroying your threads as you make them. Zinavunjikia ndani. So make sure that you turn that threading the die holder anti-clockwise to remove the die. You can I'll play that video so that I can show you how, so that you can see that taps are specifically designed so that when you turn them anti-clockwise, the chip-ins are able to come out. I don't know whether you can see katika hizi taps. Meno yake kuna meno, kuna row ya meno, kisha kuna space, row ya meno, space, row ya meno, space. Yeah? Those spaces are what allows those chip-ins to come out when you turn it anti-clockwise. So it is very important to remove those pieces of metal that you cut. This is known as a drill bit. That is what we use for drilling. This is known as a countersink bore for enlarging the entrance. It is important to have a lubricant. It is always important to lubricate any cutting process ambao utakuwa unafanya. Kama ni drilling, kama ni facing, turning, any machining process, lubrication is important to ensure that you get a smooth finish. I will not play the whole video. Ama mnataka ni play yote? Mnataka niirudie yote? Acha nitairudia tu. Inaonekana mnaienjoy sana. Repeat it. Always turn it anti-clockwise to remove those chip-ins. Now this tri-square ama engineer square will be your favorite tool katika workshop. It is important kwa sababu it ensures that when you're drilling ama when you're using such tools ama when you're filing your surface that it is flat. Iko at a right angle. Usipate kwamba unafanya drilling ama unafanya this threading kisha umeweka tap yako at an angle. We don't want to do that when you're working in the workshop. So use that tri-square ama engineer square to ensure that your tools are correctly aligned. Kama tuko pamoja, please unmute and say that you're present. Asanteni sana. Now, how do we identify threads? How do we identify which type of thread it is? Kwa mfano umeenda kwa workshop, utapata kuna charts ambazo zimechorwa kwa ukuta. Ukifungua vitabu kuna hizo tables ambazo zimechorwa katika vitabu. So threads are usually named. Hata screw, ukienda katika duka unataka kununua screw, utapata utaenda kwa hardware uambie huyo mtu ambaye anauza nataka screw ambayo ni M8. What this means is that the first letter will indicate the type of thread. It indicates the type of thread. So kama kwa mfano hizi examples ambazo nimeweka hapo, hizo ni metric threads. The second number ama the second term indicates the diameter. It indicates the diameter of that thread. No, yes, of that screw, the thread itself, yeah. So kuna M12, M16, M22, and so on and so forth. Hata ukienda kwa charts utazipata tu zimeandikwa hapo. Now there are other times that you will have a third number. Now this indicates the pitch distance, the distance between two successive threads. Are we together? With this designation, you can be able to identify which type of thread, its diameter, and the pitch distance. Okay? Any question? No question. Now, electrical materials. Yeah? Grace, what are electrical materials? In your own understanding, electrical materials ni nini? Na sio Grace pekee, anyone. What do you think the term electrical materials mean?
I just think there are a group of materials,
Okay.
yes, which are used in electrical work.
Essentially ni hiyo. I won't ask you to tell me kwa mtihani what electrical materials, but those are the materials that we use for electrical jobs, installations, and all that. Yeah, and this is not even for electrical materials. Yeah, solid state materials. Yeah? The classification of solid state materials in general. They're usually classified into these four major categories. We have conductors, we have insulators, we have semiconductors, and we have magnetic materials. Now, magnetic materials, nitawaachia msome. Do research and find out which type of materials these are and how we apply them in electrical works. Now, what are conductors? These are materials which allow current to flow through them. They easily allow current to flow through them. This is usually due to potential difference. When there is a change in voltage within that conductor, then current is able to flow. Now, conductors might be metals, non-metals, electrolytes, and even alloys. Yeah? And so there are so many types of conductors. Mfano wa conductor ya chuma ni gani? Which type of metal conducts electricity? Copper. That is the most common one. We also have silver. Silver is the best conductor of electricity. Lakini hautaipata tunatumia silver kutengeneza conductors because it is very expensive. We have non-metals kama graphite. Unaambianga usiweke penseli katika socket, lakini ukitaka kuweka charger, kitu ya kwanza unaweka kwa socket ni penseli. That black graphite in your pencil can get you electrocuted. It's a very good conductor of electricity. Ionic electrolytes. When you take ionic salts and mix them in a solution, you get an electrolyte. Mfano maji. Maji itakupiga shock, it will conduct electricity. Now, conductors can either be those that can conduct electricity easily because they have a high conductivity rate, or those conductors that have low conductivity, they have a high resistance. Both of them are conductors. They do allow electricity to pass through them, but kuna ile ambayo ita allow electricity to pass through them easily, and those with high resistance will have low conductivity. Okay? Now, depending on now let us look at some of the properties of conductors. And I've just mentioned your resistance. There are some conductors that have high conductivity because they have a low resistance, and that is the most common that we see, we use around. The ones that we use to transmit power and current have high conductivity. But we also have those that have high resistance. Kwa mfano ile tungsten ambayo inapatikana katika bulb, that is still a conductor of electricity, but since it has a high resistivity rates, then that electricity is converted to light and heat. The same kama ile heat ambayo unanunua unaweka ushago kwa sababu kuna joto, kuna baridi. That electric heater is also, those conductors are conductors of electricity, but we use that high resistance of that conductor to produce heat. So conductors may be of high resistance, some of low resistance. Now inductance. I'm sure you have come across this term in other units. Mkisoma kuhusu mambo ya stima. So you have come across this term before. Ama hii ndio mara ya kwanza mmeisikia? Have you come across the term inductance before?
I've just seen it.
This is your first time nini inductance? Kusikia inductance?
I have seen it.
Now, when we talk about inductance, now what happens when you pass current in a conductor? A magnetic field is usually formed around that conductor. Sawa sawa? Now, this magnetic field, when you form it, when it forms around a conductor, you'll find that you have an external field around the conductor, and you also have an internal field in the conductor, but that field ambayo iko ndani ya conductor is negligible, ni kidogo sana. Now, these magnetic fields interact. Kunakuwa na linkages of flux. The magnetic field, the lines of magnetic field are called flux. So there is flux linkage, they interact. So what happens is that there is a voltage, an EMF induced in that conductor. Now that EMF that is produced will oppose the current that is causing that EMF to be produced. So if current is flowing in this direction, the induced EMF will be flowing in the opposite direction. This is what we call inductance. Are we together? Now, in a DC situation, DC current, the magnetic field formed around that conductor is constant, because DC is constant in nature. But in AC, kwa sababu AC ina change, it's an alternating quantity, then these magnetic fields also change. So they change in value, so they interact. And that's why you have an induced EMF that is being formed in the opposite direction as the current flowing in that conductor. Now, how does this affect conductance? The conductivity of a conductor. If for example, when you're transmitting power for long distances, kumbuka we produce power in AC from the generating stations. That power, if you're transporting it in long distances, we have to take into consideration that aspect of inductance, kwa sababu we'll have voltage drop that as you transport that voltage. So that the longer the wire, the higher the voltage drop because of inductance. So when you're choosing an inductor, a conductor, then you have to take into consideration how the value of inductance will affect the transmission of power over long distances. Over short distances, it might not be an issue. Kama sisi ambao tuko Mombasa, utapata power inakuwa produced in those 7 fork dams, which are hundreds of kilometers away. So when you're choosing a conductor that will transmit that power, then you have to choose one whose value of inductance will not affect the voltage drop to be too much. There is an allowable percentage that is usually recommended by the regulation bodies. You don't want the voltage drop, the lost voltage, to be more than the voltage that you're actually supplying. Now, electric field inside the conductor is 0. Now, what this means is that if there was an electric field in the conductor, this field, this magnetic field, will produce a force that will act on the electrons. Remember, electrons are what are causing the electricity to flow through the conductor. So if there was a field, then this force will act will push the electrons and make them immobile, hazingesonga. But since there is no force in that conductor, then the electrons are free to move. That's why we say that electric field in the conductor is 0. Now, since there is no field in the conductor, then electrons. Remember, electrons are negatively charged particles. what happens when you bring particles that are like whose charges are similar? Mambo ya magnetism, they will repel. So utapata kwamba these electrons, because they are negatively charged, they will be as far away as possible from each other. So the electrons tend to go onto the surface of the conductor. So inside the conductor, the charge density, hakuna, it is 0. That stima sana sana inapitianga on top of the conductor, something known as skin effect, because the electrons are usually may repel. Electrostatic repulsion has made the electrons to be on the surface. Now, since the electrons are on the surface, then that means that the free charge only exists on the surface of the conductor. Zime repel the electrons zikaja kwa surface. Are we together? Now, on top of the other properties that I know you have written, easy subtopics najua mmekuwa nazo, mmekuwa na time. On top of the ones that you have, you can add the ones that I've mentioned. Sawa sawa. Now, we had already mentioned some types of conductors. We have the metallic kama copper, aluminium, silver, gold. We have non-metals, mfano graphite na platinum. We have electrolytes kama maji and other ionic salts. When you mix them with solutions, there, those that can conduct. And you, as a person, you have ions in your body. That's why you transmit electricity. Now, what are insulators? Insulators ni nini? We have conductors which allow heat to pass through them freely, heat and electricity. We also have insulators which do not allow the passage of heat and current. Now, types of insulators become plastic, glass, rubber, air. Depending on the application, then we can have different types of insulators. Now, what are some of the properties of insulators? They have high resistance. That is the reason why they do not conduct heat and electricity easily. They have large dielectric strength. What does this mean? Dielectric strength is that maximum voltage that a conductor can withstand before it fails. Najua ni umeiweka charger ama cable ama pasi, ukapata ile cable imeungua. Hii ni kumaanisha kwamba your your insulator imepitisha the dielectric strength that it's rated dielectric strength. So you have to ensure that the insulator that you choose can be able to withstand those voltage stresses so that it doesn't fail. We don't want our insulation failing. So it must have a large dielectric strength. Now, they also need to have high mechanical strength, and this is usually prevalent when we are talking about installations hizi ambazo cable ni kubwa. If you're going to be installing cables whose weight is 1,000 kilograms, 2,000 kilograms, then the insulator that you choose for that cable then has to be able to withstand that weight and the tension of that wire. The chemical property and the electrical property of that insulation should be able to withstand the elements. Si ati nikiweka charger kwa jua ina melt. It should be able to withstand temperatures. Remember, we are going to be putting our insulation through different environments. Then you have to ensure that those insulations can be able to withstand those elements. Now, they should be free from unwanted impurities. Once you have impurities in your insulation, then this inafanya your insulation to become conductive. It can be able to conduct electricity. For example, if I have metallic impurities in my conductor, I can be electrocuted easily because those metallic impurities will conduct electricity. Now, we have other types of materials known as semiconductors. Now, these are materials whose properties, conductivity and resistivity, are in between those of a conductor and that of an insulator. Sawa. These are common in electronic devices. Ukifungua simu yako, laptop, TV, utazipata hapo zimejaa. Transistors, diodes, integrated circuits. Those electronic devices that do calculations, those integrated circuits are semiconductors. Now, semiconductors can be of two types, two major types. You have intrinsic and we have extrinsic. Intrinsic are the pure, those are the pure semiconductors. Zile ambayo when I go to nature and I mine that material, the one that I find pure, the pure chemical form of a semiconductor is known as an intrinsic semiconductor. An extrinsic semiconductor is when I take a pure, an intrinsic semiconductor and I put impurities into that semiconductor, then what I get is an extrinsic semiconductor. Now, depending on the type of impurity that I add, then it can become more of a conductor or it can become more of an insulator. If I add metallic impurities, it becomes more of a conductor. If I add impurities that do not conduct electricity, then it becomes more of an insulator. For intrinsic, the pure semiconductors, their conductivity and their insulation properties is usually purely dependent on temperature. Yeah? So when I increase the temperature, the conductivity increases. When I reduce the temperature, then the conductivity reduces. At zero temperature, at 0 Kelvin, for a pure semiconductor, at 0 Kelvin, not degrees Celsius, 0 Kelvin, it becomes a perfect insulator. So when I increase temperature, then the conductivity will also increase. Now for extrinsic, the type of insulator, there are usually two types of impurities that I can add. There is a pentavalent type of impurity and there is a trivalent. Pentavalent adds 5 atoms to the semiconductor. A trivalent adds 3. On a pentavalent type of impurity and a trivalent type of impurity. This usually gives rise to p-type semiconductors and n-type semiconductors. I'm sure you've heard the term PN junction mahali. Niko sure umesikia mahali PN junction. And if not, you're going to come across it. Because we are all electrical engineers here. Those are the diodes, the transistors use that the PN junctions. Now, what are some of the properties of semiconductors? The ones that I have listed are the major ones. I didn't want to put the ones that are too complicated. Nimechagua the easiest. Ile ya kwanza ni kwamba the properties, the conductivity and the resistivity of a semiconductor usually lies in between that of a conductor and an insulator. Depending for the pure semiconductors, it is dependent on temperature. For the extrinsic semiconductors, then it is dependent on the type of impurity you add. Now, they have a negative temperature coefficient of resistance. Sana for the pure ones. When I increase the temperature, then the resistance reduces. When I reduce the temperature, then the resistance increases. This is known as negative. For the negative temperature of coefficient U, reduce temperature, resistance in increase. This is usually seen in the pure semiconductors. Tuko pamoja mpaka hapa? If you're together, please unmute and say that you're present.
Present.
Now.
Present.
Thank you.
Present.
Now we will talk about cables. This is cables. And before I talk about cables, I want to ask a question. What is the difference between a cable and a wire? Tofauti ya cable na wire ni nini? Why don't you ask your neighbor ama your friend, nisaidia wire ni charge simu? Mbona uambiange beshte yako nataka nisaidia wire ni charge simu? Tofauti ya wire na cable ni nini?
Wire is just a conductor, while a cable is a conductor and an insulator.
You are very correct for the first one, but ya pili umepotea kidogo. Remember, insulation inategemea na kazi ambayo unataka kutumia hiyo cable ama wire. So there are some cables and wires that don't have insulation, and there are those that do have insulation. Now, Grace ulikuwa unasema kitu?
I think
Aha. Amepotea.
Let me try.
Try.
I think
Aha.
they were connected completely while the cable is
The wire is?
a wire
Uh-huh.
while the cable is an insulator.
Nice try, but that's not the answer.
The wire is the conductor,
Uh-huh.
while the cable is an extension, which most of the time it is sheathed.
Uh-huh.
Cable kuna conductors mingi lakini wire is only one conductor.
That is correct. Wire ni moja, strand moja. Cable ni wires ambazo zimekuwa grouped together. So those wires can be grouped together individually ama zinaweza kuwa zimeshonwa pamoja, but as long as you have more than one wire, then that becomes a cable. If you ukikata your charger ama extension ama whatever, you'll find more than one wire ama conductor in that sheath ama insulation, then that becomes a cable. But if you only have one, then that becomes a wire. Now, what we are going to be talking about today sana sana are power cables. Remember, cable ni za aina nyingi. Kuna ile ya video cable ambayo una connect decoder na TV. Kuna ile ya fiber optic ambayo ya internet. So there are so many types of cables. So the one that I'll focus on today sana sana are electric power cables, and these are the ones that we use to transmit and distribute power from one place ama from the generating points to where they are needed, to the load. Now, what are the components of a cable? Nilikuwa nimeuliza watu waandika hizi notes, and fortunately or unfortunately some people sent me the notes wakidhani ni assignment nilikuwa nimewapatia. And when I ask people to write notes on construction, mtu akaniandikia the process of kutengeneza cable. No, when I talk about construction, I want you to tell me what a cable is usually made of. Now, the three major components of a cable. Utapata kuna conductor. For the power cable, that is, kuna conductor. There is a dielectric ama an insulator, na kuna sheath which usually adds protection. Now, a conductor is what we transmit the power, the current using from one place to another. The insulation is what isolates you from that conductor, ili usipigwe shock. Now, the sheath is what offers mechanical protection to the inside of the cable, to protect the cable ama the insulation and the conductor from moisture, from dust, from all those external things that may affect its performance. So we have sheath. We sheath the cable. You can look at for example, hii charger ambayo natumia saa hii. This top hii ambayo imefungwa juu yake ni uzi imeshonelewa juu yake. That is a sheath that adds protection to my charger. So the sheath might be metallic, might be rubber, might be plastic, so many types depending on the application of that cable. Now this is a diagram that shows the basic construction of a cable. You have the conductor which transmits the current and the voltage. We have the insulation which is isolating the conductor from the external environment. And in this case, this is a three-phase cable, kwa sababu it has those three phases denoted by those three colors: yellow, blue, and red. We have the sheath. The sheath is what naomba mnipatie dakika kidogo nichukue simu. I'm so sorry. Yes. Hello.
Kwa hii class kwa baya. Tuache kama kwa class.
Mbaya kabisa. Mbaya. Kilele mnyamazi. Alafu wiki wengine sasa.
Kumbe kuna watu kwa hii class wamenyamaza, wanangoja tu nitoke ndio. Kumbe I have other people in this class. Wanangoja tu nitoke ndio wanaanza, mshaanza hata Okay, wacha tumalize haraka so that twende. Mmesikia watu washaanza kupanga sherehe na tuko class. Okay. Inaisha tu saa hii tu. Namalizia. Now, conductors, no. Niki?
Ukikuja class, manake saa zingine saa hii tuko na class zingine. Class rep haja to show.
Nilimwambia kitu 12 ama ni saa ngapi?
Imagine hata tujaona messages zake, tunaingia class kama umefika class na tujisa mnyomanza class.
Okay, pole. Nitakuwa naandika kwa Google Classroom Yes? Nimesikia nitaweka. Sema class rep.
Achana na wana complain bure. Waliambiwa kwa group.
Okay.
Hakusema.
I'll be posting kwa just know, yeah, class ni 3:30 unless nimesema otherwise. On Friday ni 3:30.
Post kwa Google Meet.
Nitakuwa naeka kwa classroom. Nitakuwa naiweka kwa classroom.
Na si mob sana pia. Weka ndogo ndogo.
Sawa. Okay, acha tumalize ndio tuende. Now, cables, vile tulikuwa tumeona katika threads that we have ways of identifying threads, then it's also possible to identify cables. Now, we have this denotation ambayo iko na number na letter. Now, for the first number usually indicates the number of wires. The number of wires in that cable ndio inakuwa represented na that first number. So kuna 7, 19, 37, 45 na kuenda juu. The second letter indicates the size of that individual wire. Hiyo wire moja diameter yake in millimeters ama centimeters is usually denoted by that second letter. Now insulation kutegemea na ile kazi ambayo unafanyia hiyo cable, unaweza tumia rubber, unaweza tumia PVC, ile plastic pipe, unaweza tumia polythene, unaweza tumia so many different types. Kwa mfano ukifanya installation katika meli, utapata insulation ya meli na insulation ambayo iko kwa nyumba zetu ni tofauti, because the ocean and the ship environment is more harsh as compared to your house. So utapata insulation ya meli is halogen free, so that when it burns, in case there is a fire, it does not produce toxic fumes. Lakini ile insulation ambayo iko kwa nyumba ukichoma tu kidogo inatoa fume mbaya. So the insulation differs with regard to the application. Now sheathing is that adding an extra protection on top of your insulation. You can add a paper, you can add paper, you can add hessian, you can add PVC. The sheath can be metallic in nature, depending also on the type of cable, and that's why I gave an assignment so that you can find out the different type of cables, ndio ili uweze kuona the different types of the different types of construction. Utapata kuna cable ambayo iko na one conductor, so that becomes a single core cable. Utapata kuna cable that has three conductors, that is a 3-core cable for 3-phase transmission. Sheath, so sheath ni tofauti, okay. Armoring is another important part of a cable. You will find that kuna a sheet of steel ama aluminium that has been put inside the cable. Sana sana for this big easy cable no. They have a metallic sheath, a metallic armor. This is just to improve its mechanical properties, mechanical strength. So this the armor might be a circular piece of metal, a sheet of metal, ama inaweza kuwa ni kama braid ya kama ile wasichana, chuma imekuwa woven in braids around the cable. Now armor, in some cables, kama there's a cable known as a mineral insulated cable, kuna conductor which transmits the live current. We have an insulation which in this case is not rubber or the like, it is iron oxide, it is a mineral. And then on top of that there is an armor, ni metallic in nature, hakuna insulation, ni armor. So this armor acts as a neutral, is the return wire. So the armors can be used as neutral connections. So it is very important if you have an armor in your cable that it is grounded. You have to ensure that armor is grounded, so that isikuwa ni a neutral na kisha ukaishika ukapigwa shock. No. So make sure that in your cable the armor is grounded. Now on top of all that, you might find that there is another sheath ambayo imewekwa around ama on top of your cable. Now this is usually to protect it from mechanical forces, ili isikuwe damaged by mechanical forces. Now what are some of the factors we have to consider when choosing cables? The first one, now there are so many, but I listed a couple. Kuna cost, there's so many, but I chose these 4 because these are the most important. Now under a cable installation, you have to remember that hizi cables ambazo tunataka kutumia are of different types. Yeah? So wewe ambaye unafanya hiyo kazi have to be conversant. You have to be knowledgeable. You and your crew have to be knowledgeable on the type of cable ambayo unatumia. What type or which the tension that you have to tighten ama loosen your cable. Usiende ukakaza cable yako ikakuwa too tight. You also have to take into consideration, is it an outdoor installation ama is it an indoor installation? So you have to be aware of your you have to have a good understanding of your local conditions. Cable construction, we have seen that kutegemeana on the type of cable, the construction differs. So you'll find that kuna cable ambazo ziko na a sheath, there are some that do not have. There are those that have armor, there are some that don't have. There are some that have insulation, there are some that do not have. The conductors, the arrangement of the conductors. Kuna ile ambayo ni single core, kuna ile ambayo ni 3 core for single phase and 3 phase transmission. The arrangement of that cable. So there are so many things you have to consider when it comes to the construction of cable, but all this is dependent on the type of cable that you're using. Now, cable operation. Remember that your cable has an insulation. This insulation should be able to withstand the voltage stresses experienced during normal and operating conditions and during abnormal operating conditions. Sasa kukiwa na shida kidogo cable yako your insulation fails. There has to be that allowable limit that your insulation of that cable can withstand. Cable size. Cable size is one of the most important factors to consider. Cable size can be a topic on its own. Tunaweza cover cable size a whole semester because there are calculations that are usually done so as to determine the perfect size of the cable. Now, what are some of the factors you consider while choosing cable size? The current carrying capacity of that cable. There's a code which is known as National Electric Code that is used to that lists the different cables and their current carrying capacities. We have voltage regulation as another factor that is used to determine the cable size. Yeah. Remember when we talked about mambo ya inductance, tukasema kwamba the voltage drop, there's an allowable voltage drop that is specified by these bodies, and sana it is usually up to 5%. Beyond 5%, then there is going to be a problem. You will have lost too much voltage. Okay, you cannot lose more voltage than you're supplying. So there is an allowable voltage drop. Then we have another factor that is you should consider when choosing sizes: the short circuit rating. Short circuit rating. When there is a problem like a short circuit or a fault in the current, then your cable should be able to withstand that fault before it is rectified, before it is removed by these fuses or circuit breakers. Those are the rectification devices that you install for protection. Sasa kukiwa na fault kidogo, cable yako inaungua ama inaharibika before those rectifying devices get their chance to fix that fault. And so on and so forth. There are so many factors to consider when choosing cables, but these are some of the most important ones. Now, under the size of cable, as I've said, this is usually ni topic kubwa, because you have to calculate. Now, there are some rules you have to consider when you're doing these calculations. When you're choosing the size of cable, you have to add 20%, even up to 50% of the total size. Why? You have to take into consideration future expansion needs. You have to take into consideration emergency needs. Do not be constant. Sati umefanya calculation, umepata that the size of my cable is 10 millimeters, kisha ukeka 10 millimeters. No. In your calculations, always make sure that your final size is 20% more than the rated one, so that it can be able to handle these emergencies, future expansion needs. The voltage drop, allowable limit yake is up to 5%. Remember, the bigger the cable, the bigger the size, the bigger the voltage drop. So you have to take in consideration, and this voltage drop is usually the most important factor when you're doing these calculations. You have to calculate those voltage drops, then factor in now those factors zingine kama additional size for expansion, the temperature factors and all that. But once you calculate the voltage drop, then it is possible to get the size. the change in temperature, ama the ambient temperature. The bigger the cable, the more heat it will produce. Remember, once you pass current through a cable, then heat is produced. Then that cable should be able to withstand the ambient temperatures, ama the temperatures surrounding your cable. Type of wiring system. I cannot, there are very many types of wiring system. Kuna overhead, ile ambao unaweka kwa ceiling. Kuna underground. I cannot put 1,000 kg, 2,000, 5,000 kg wires overhead. So the type of installation will also determine the type of cable you're going to use. I mean the type of wiring system. There are so many. Concentric, overhead, underground, bus bar, mingi sana. Are we together?
Yes.
Now for topic 2 tunamalizia hapo. We have covered much of what we were expected to cover. So unless there is a question, we are going to end there for today, so that next week when we meet, we are going to start on topic 3.